In this video, we're going to finish the percentage concentrations by taking a look at some mass problems. You will see that there are some pause, try, play segments included, and also a few extra practice problems from the textbook that you can try out with the answer keys provided. There. Just a couple things to point out with these answer keys. In this textbook, they refer to mass volume as weight volume, and mass as weight, but they mean the same thing. And then you'll see, yes, so you can try those after you're done trying the examples in the video, and the pause, try, play as well. So let's go to our handout and try these examples out. So remember that percent mass is mass of solute over mass of solution, and they're both in grams, so being consistent is important, times 100%. This is a long question here. Calcium chloride can be used instead of road salt to melt the ice on roads during the winter. To determine how much calcium chloride had been used on a nearby road, a student took a sample of slush to analyze. The sample has a mass of 23.27 grams. So that looks like that's the entire sample, which would be our mass of solution. When the solvent was evaporated, the residue had a mass of 4.58 grams. Assuming that no other solutes were present, what was the mass percent of the calcium chloride in the slush? So basically, the leftover is considered to be our calcium chloride because we're saying that there's no other solute there. And as we can see, there's 3 sig figs in this number over here, and then 4 in this one. So we're going to go with 3 sig figs for our final answer. So we know that the percent mass is equal to the mass of the solute, which is the calcium chloride, over the mass of the entire solution or the entire slush, and both in grams, times 100%, which is going to be equal to the 4.58 grams over the total mass of the solution, 23.47 grams, times 100%. And so that will give us 4.58 divided by the 23.47 times 100. And we get approximately 19.51427354%. Don't forget it has to be to 3 sig figs, so approximately we can round down to 19.5%, and we can say therefore percent MM. So therefore the percent mass of CaCl2 is approximately 19.5%. And that's rounded to 3 significant figures. So 3 significant figures. So that there is our final answer for that first question on mass. Let's take a look at the next one. What mass of salt is dissolved in 6 liters of a 3.44% by mass solution? So a 3.44% by mass solution. So when we look at this question, we need to take into consideration what the mass of the solution is going to be. Now, we're looking at an aqueous solution here. And so I want to be clear what that means for us in terms of the mass, because it looks a bit complex, and I'm referring to this note here. So if we're looking at an aqueous solution, we're going to assume that the density of that solution is going to be the same density of water. And the reason I'm assuming that in this case here is only because it's a pretty small percentage by mass. And for the most part, if I don't tell you otherwise, we can assume that in our aqueous solution, that this can translate to the mass because it has the same density as water. So let's go and take a look at that. So this is an aqueous solution here. It's dissolved in water, in other words. What this means, remember, is that for water, the density is 1 gram is equal to 1 milliliter. Now, 6.0 liters is 6,000 mils. Okay. Now, I didn't keep the right number of sig figs here. It should be 2 sig figs, so I'd write that as scientific notation, but I'll do that afterwards. So the 6,000 mils, because we're assuming the density of water, 1 mil is 1 gram. That's also equal to 6,000 grams, okay? Or 6.0 times 10 to the power of 3 grams. So that can be the mass of our solution, okay? And that's because it's a small enough percentage that we can assume the same density. So there's some error there, but it does work out for a question like this. And so this is a 3.44% by mass solution. So we're looking at mm here. So what do we know? We know that the percent mm is equal to the mass of the solute, which is the salt, over the mass of the solution times 100%. So if we want to find the mass of the salt, the solute, we'd have to say that the mass, so mass of solute, we rearrange our equation, is going to be equal to the percent mm in this decimal form multiplied by the mass of the solution. So that's going to be, so let's do step 2 here. The mass of solute, I'm just plugging in my numbers now, is going to be equal to the 0.03440, that's the 3.440% in decimal form, times the mass of the solution, which we found was 6,000, or 6.0 times 10 to the power of 3, to keep our proper number of sig figs, which is 2. So that's our times 6,000 grams here. And then that's going to be our answer. So we're going to have 6,000 times 0.03440. We get approximately 206.4 grams. Now, we do need to make sure this is rounded to a proper number of sig figs. We want 2 sig figs. So we can say that to 2 sig figs, we need to be about over here. So we can round that up to about 210 grams. So we can say, therefore, the mass of salt is approximately 210 grams. And so that's, again, 3.44% mass. We were able to assume that the mass of the solution is equal to the volume of the solution because it's a dilute aqueous solution. I wouldn't necessarily trick you with that. I would tell you if there were other considerations you need to take a look at when it comes to a question like this. But in a very dilute solution, we can assume the same density. So if we had 6 liters, that's really 6,000 mils, which is 6,000 grams. So our milliliters would be equal to gram because the density of water's density is 1 gram per mil. So let's go take a look at our final example here for mass problems. A student wants to dissolve 18 grams of salt in water to form 28% mass salt solution. What volume of water should be added to the solute to prepare this solution? Okay, so let's take a look at our formula again. So remember, we have percent mass is equal to the mass of the solute, so the salt, over the mass of the solution. So it's the salt and the water together, times 100%. So we want to find the volume of water. We have the percent mass. So let's first start to find the mass of the solution, because the mass of the solution actually has the mass of water in there. Another little reminder I need to let you know again is the density of water is 1 gram per mil. That will be significant for this scenario here. So we'll find the mass of the solution through our rearranged formula, and then from there we can go ahead and find the volume of water that should be added. Now, let's go ahead and write this in a modified way. Let's fill in some numbers here. So we have 28% mm. So essentially, to write that out, we'd have 28% is equal to the mass of the solute, 18 grams, over the mass of the solution, which is 18 grams plus the mass of water. We don't know what that is. We're going to find that. Because once we have that, we technically have the volume, because the mass of water is equal to its volume, if it's grams to mils, times 100%. And so I'm going to rewrite this in decimal form here. So basically divide by 100 on both sides. So 0.28 is equal to 18 grams over 18 grams plus the mass of water, but I'll just call that X. And I'm going to rearrange this to solve for X. So I'm going to get 0.28 times 18 grams plus X is equal to 18 grams. And we're just going to simplify here. So expand and simplify. So I'm multiplying everything in here by 0.28. So I'll get 0.28 X plus 0.28 times 18 is 5.04 grams is equal to 18 grams. And so then I'm going to rearrange and I'll get 0.28 X is equal to 18 grams minus 5.04 grams. And so that'll be 0.28 X is equal to the 18 minus 5.04. And I'll get 12.96 over here. And I'm just going to finish the work up here. So I'm going to keep going up here. I'll get, so 0.28 X is equal to 12.96. To solve for X, I need to do 0 divided by 0.28 on both sides. And I'll get X is equal to 46.28571, so on and so forth, which is, so this is in grams, keep in mind, because we found the mass of water over here. So I'm going to do this next step over here. So we found that the mass of the water is equal to 46.2857 grams. Now, here's what we know. Since the density of water is equal to 1 gram per mil, what that means is that the mass of the water is going to be equal to the volume of the water in milliliters. So they're the same. It's 1 gram for every 1 milliliter. Okay, so I'm just putting here in mils and mils. So in other words, therefore, the volume of water is going to be 46.2857 milliliters, because it's 1 gram per mil. That's where this density comes into play. So we'd have to add 46.285 milliliters to equate to our mass that we have there. And don't forget, this needs to have the proper number of sig figs. So it looks like 2 sig figs. So we're going to have about 46 milliliters of H2O, which is 46 grams. So that one, you had to remember that the mass of the solution is the salt and the water together. And this works out nice and easily because the mass of water has the same density. So the mass of water is going to be the volume of water, since they have a density of 1 gram for every mil. In other words, if you have 1 gram of water, you have 1 mil of water. And that's how we're able to directly convert that way. If they didn't have the same density, we'd have to use density formulas to figure out what the volume actually would be. So those are the types of questions you would see for mass percent, or percent mass. This one was a bit of a thinker, because you had to take into consideration the volume of the mass of the solution being both your solute and your solvent together. So just keep that in mind when you're doing your questions going forward. So that would conclude the problems with mass. So you can try out the questions in the textbook over here as well, just for some extra practice, and see that you're on the right track with your answers. And then in the next video, we're going to take a look at the type of concentration units we'll use for very low concentration.